Okay, so let's look at graphing trig functions again from the beginning. So our trig functions come from our unit circle, looking at our x and y values. So sine has the pattern we discovered that we want to memorize. That goes int, max, int, min, int. Int is an intercept at 0, maximum at 1, intercept, minimum, intercept. So here's our basic sine graph. Looks like a snake, starts at 0. Cosine, we decided, went max, int, min, int, max. Starting at 1, maximum, intercept, minimum, intercept, maximum. Looks like a cup. So if you need to look back at those patterns again, please go back to the original notes. Okay, looking at tangent and cotangent, again coming from the unit circle. Tangent and cotangent have periods of pi, unlike sine and cosine, which have periods of 2 pi. This means the tangent and cotangent graph make one full cycle between 0 and pi. Tangent has at 0 intercept, then it has a positive point, it's undefined, it has a negative point, and then an intercept again. This intercept happens at 0, this next intercept happens at pi, the undefined is halfway in between at pi halves. So that looks like intercept at 0, undefined at pi halves, intercept again at pi. That's one period, and then it repeats. Undefined, intercept. The positive and negatives happen at 1 and negative 1. That's halfway between 0 and pi halves, which is pi fours. So there's going to be a positive, and there's going to be a negative. Then again, positive, negative. So you can see the graph approaches positive infinity on the left, negative infinity on the right. Cotangent, we take the reciprocal of all those points. So this first intercept becomes undefined at 0. The positive remains positive at 1. The undefined becomes an intercept at pi halves. The negative remains a negative, and the last intercept becomes undefined at pi. So now we have an asymptote at 0, an asymptote at pi, an asymptote at 2 pi. Again, 0 to pi is one cycle, and then it repeats. Your intercept is halfway between at the pi halves. You are positive on the left, negative on the right. Positive, negative. Okay, so that's getting down to the basic tangent and cotangent. If you want more details on that, please go back in the tangent and cotangent notes. Okay, and quickly looking at cosecant and secant. Remember, cosecant is the reciprocal of sine. Secant's the reciprocal of cosine. So I have here the basic sine and cosine curves, and all we're going to do is take the reciprocal at each point. So looking at the intercepts, here, here, and here. Your intercepts are 0. The reciprocal of 0 is undefined. Those are where your asymptotes occur. The reciprocal of 1 is 1. We are basically just taking this parabola here and flipping it upside down. We're taking the reciprocal at each point. That graph becomes inverted. Looks like this. For secant, your intercepts are at pi halves and 3 pi halves. That is where your undefined asymptotes are. And then again, we just flip the rest of the curve. So that's what your cosecant and secant graphs look like. Those are the basic graphs, and then we worked on transforming them. So we have all of our equations in this form. Again, this part doesn't matter. This applies to all of the functions. A, the coefficient to the trig function, is your amplitude. That is how high your graph goes from 0. B indicates a change in change in period. Change in period. So you take 2 pi, this period of sine or cosine. If you're working with tangent or cotangent, it would be pi, and divide it by b. And that's how you get your period. C indicates a change in phase shift. Phase shift is horizontal shifting, left and right. H is a number outside of your parentheses. That is vertical shift, up and down. So the difference between phase shift and vertical shift is outside your parentheses. Phase shift is inside your parentheses, adding and subtracting to x or theta. This could also be a theta. So anytime you have something in parentheses that is not a coefficient of x, like c is here, that is when you do the two equations, bx minus c equals 0 and bx minus c equals 2 pi. This gives you your new starting point, and this gives you your new ending point. And that's when your first period is shifted left or right. So let's look at an example and do it together. Okay, so we have y equals negative 3 secant 2x minus pi plus 2. So let's look at what we have. Oops. This number here, coefficient to the trig function, indicates your amplitude. Your amplitude is going to be 3. This number here, outside of your argument, indicates vertical shift. It's positive, so it's going to be up 2. This negative out front indicates whether or not your graph is flipped. Remember, flipping just means your maximums become minimums and your minimums become maximums. So this does have a flip. This 2 is our b. So to find our new period, we're going to take 2 pi, divide it by 2, and now our period is pi. That means instead of completing one full cycle between 0 and 2 pi, we are now going to complete one full cycle between 0 and pi. This minus pi here indicates a phase shift, so we are going to say 2x minus pi equals 0 and 2x minus pi equals 2 pi. This is our original starting point, our original ending point, and now we're going to find our new start and our new end. Solving this algebraically, we get 2x equals pi, x equals pi halves. This is positive, so this means we are shifting to the right pi halves. When we look at this one, we get 2x equals 3 pi, divide it by 2, x equals 3 pi halves. This is our new end. So we are going to complete one full cycle of the secant graph between pi halves and 3 pi halves. Secant, however, is the reciprocal of cosine, so we are going to graph the cosine graph first. So first I'm going to create my units. I'm starting at pi halves. So here's pi halves, here's pi, here's 3 pi halves, here's 2 pi. And let's go in the negative direction a little bit. Negative pi halves, negative pi. My shift is up 2. That means my new midline is now at positive 2. This is where my intercepts are going to happen instead of happening on the x-axis. From this point, my amplitude is 3. So I will go, my maximums will occur at 2, 3, 4, 5. My minimums will occur at negative 1. That's 3 here and 3 here from the midline. Oops. Okay, so our full period is taking place between pi halves and 3 pi halves. So between those two endpoints, I need to have 5 critical points. That means I'm going to have a critical point halfway between pi and pi halves, and a critical point halfway between pi and 3 pi halves. And I am graphing cosine with a flip. So that pattern is going to look like min, int, max, int, min. I've taken my original pattern and I'm just flipping it. Flipping my maxes and my mins. So here comes cosine. Cosine is going to start with a minimum, This, the midline, remember, is now where my intercepts occur, so my first minimum will be at -1. My intercept will be at +2. My maximum will be at 5. My intercept will be at +2. And my minimum will be at -1. If I do another cycle between pi halves and negative pi halves, I'm going to have an intercept at pi4, a maximum at 0, an intercept at -pi4, and a minimum at -pi halves. And I'm going to connect these curves here. Okay, so that is the graph of cosine, the negative cosine, with an amplitude of 3 and a vertical shift of 2, a horizontal shift of pi halves, and a period of pi. Now I'm going to take the reciprocal of this graph. So every time there is an intercept, my intercepts happen at the midline here, those have a value of 0. The reciprocal of 0 is undefined. So that is where your asymptotes will happen. Your maximums here and here now become relative minimums. So you flip the parabola, reflect it vertically, and your cosecant or your secant graph will look this way. Your minimums become relative maximums. So again, you're just flipping all the points between the asymptotes. And that is how your secant graph should work. So please rewind, listen again if you need to. Go back and look at the original notes. Come find me if you have any more questions. And hopefully we can do some practice in class and get us a little better understanding on this topic.